All right, today we are moving on to 7.3, multiplication properties of exponents. All right, so we're just learning a couple rules that we use. So this when in doubt, expand it out, that's going to be a lifesaver, all right? And it gives you a very good visual as to what's actually going on. All right, so product of powers means multiplication with the same base. All right, so the x in this case is our base, not the exponent, right? So the bases are the same, but the exponents might be different. So if this is the case and you're multiplying, then you want to add the exponents. All right, so this first example, x squared times x cubed. So we have the same base, they both have an x, all right? So if I add my exponents, 2 plus 3, that gives me x to the fifth. All right, but we don't want to just see what happens, we want to see why it happens. All right, so if I take that x squared and I expand it out, it's x times x. Times, if I take x cubed and expand it out, x times x times x. So you can see we have x times x times x times x times x. All right, we just have 5 x's multiplying together, so x to the fifth. All right, so expanding it out gives you a nice visual, but the property says if you're multiplying with the same base, you add the exponents. So let's do another one over here. X to the fifth times x to the fourth. Well, if I just add my exponents, it's just 5 plus 4 is 9, so x to the ninth. If I expand it out, x to the fifth is x times x times x times x times x. X to the fourth is times x times x times x times x. All right, and remember these are multiplying together, so everything is multiplying together. So we can see visually we have 9 x's, so x to the ninth. All right, now we have actual values. So this one we're going to do 2 separate ways. First is if we do it separately. 4 squared is 4 times 4. 4 cubed is 4 times 4 times 4. So actually I lied. We're going to do it 3 ways. All right, so if I wanted to do that, just 4 times 4 times 4 times 4 times 4, I get 1,024. Another thing I could have done is 4 squared is 16, 4 cubed is 64. 16 times 64 is, in fact, 1,024. The third method we could have done, which uses our exponent properties, as you can see, we have a base of 4 and a base of 4. So that means I want to add my exponents. So 4 to the 2 plus 3 power, or 4 to the fifth, which we actually did right there, and we get 1,024 again. All right, last one for this example, x cubed times y squared. All right, this in fact equals x cubed y squared. All right, even if we expand it out, we have x times x times x and y times y. We can't combine the x's and the y's, right? It's like apples and oranges. So we have 3 x's, 2 y's, which gets us x cubed y squared. All right, so that is our first product of powers property. Now we are going to move on to product of a power. All right, so power to a power is a little different. Now we're taking something with an exponent and raising it to a second exponent. All right, so if it's an exponent raised to another exponent, then you want to multiply them together. So in this first example, we have x squared raised to the fourth. So if I follow my pattern, I just multiply 2 times 4 to give me x to the 8th. All right, but let's see what's really going on. First, we can see this x squared is being raised to the 4th power. So that x squared is being multiplied by itself 4 times. So that's like an x squared times x squared times x squared times x squared. Well, I could even take it further and expand out each of these x squareds into x times 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 x. So all of our x's are multiplying together. We can see x is being multiplied by itself 8 times. So again, we get x to the 8th. All right. Second one, b to the 4th raised to the 5th. If I know my exponent properties, I just multiply 4 by 5 to get b to the 20th. All right, but to fully expand it out, we're taking b to the 4th, and that's being multiplied by itself 5 times. So b to the 4th times 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 b to the 4th. And I can expand each of these b to the 4ths out. So 1, 2, 3, 4. 1, 2, 3, 4. All right, so I'm multiplying b together 4, 8, 12, 16, 20 times. So b to the 20th. All right, next one, w to the 3rd. All right, we can think of this as w to the 1st. All right, so if I multiply my exponents, 1 times 3 gets me back to w to the 3rd. And that would make sense if we have just w to the 1st times w to the 1st times w to the 1st. It's just w times w times w. So that one was fully simplified. All right, and this last one, x to the 0th raised to the 7th. So using our property, multiply the exponents. 0 times 7 gets us x to the 0th, which is 1. How do I know that it's 1? Well, anything that I plug in for this x, when I raise it to the 0th power, it's always 1. Anything to the 0th power is 1. So a second way I could have done this is I could have recognized right away that x to the 0th power is 1. And if I raise 1 to any power, it's still 1. All right, so that is all of our notes so far today for exponents. So we did product of powers. So that's if you have a base with an exponent times that same base with an exponent. We also have power to a power. That's the one we just did where it's a power raised to another power. That's where you want to multiply them together. All right, so that's it. Let's get going on that LT check.